The projected exit path is already gone. The instruments still look healthy. Attitude markers remain steady. A signal is still reaching home. Yet the line that once showed a way back has faded from the navigation display. Saturn has no hard ground waiting below the clouds. In 2017, NASA's Cassini spacecraft entered Saturn and kept transmitting as it descended. Long before anything resembling a surface could appear, it was already committed to the fall. Saturn's gravity accelerates descending spacecraft far above the deeper atmosphere, and that changes the situation earlier than most people expect. On the display, Saturn is not a planet yet. It is a gravity map, a dark circular mass, a stack of curved paths, a descent line bending inward where it used to bend away. The last safe correction point has already slipped behind. Nothing has broken, no explosion, no collision. The spacecraft is still alive. That is the uncomfortable part. The loss happens before the destruction. A craft can become unrecoverable while every system still appears to be working. The fall has carried it somewhere that no longer treats escape as a normal maneuver. And the diagram keeps updating. A burn timer appears and begins stretching across the display. The engine icon has not changed. It is still available. It can still fire. Saturn's gravity turns every lower kilometer into a larger escape bill. Planetary measurements show Saturn contains about 95 times Earth's mass. Closer to a massive world, the speed required to leave increases. The navigation system reflects that quietly. Altitude continues dropping. Velocity keeps climbing. The burn marker slides farther ahead. For a moment, the screen suggests a simple solution. Fire longer. Push harder. Recover the lost distance. The numbers disagree. The predicted burn grows. The descent curve steepens. Velocity rises again before the correction can erase it. What looked like a location problem begins behaving like a speed problem. The engine symbol remains bright and unchanged. That detail starts to matter differently now. Another update arrives. The required burn becomes longer. The projected exit still does not open. Nothing appears damaged. The spacecraft keeps falling. The velocity readout keeps advancing, and the next correction is already asking for more than the last one. Around Saturn, escape is a path problem before it is a fuel problem. The cloud image disappears entirely now, replaced by a clean trajectory diagram. One curved line loops around Saturn, another drifts away into open space. For the first time, the situation looks understandable. Mission planners use trajectory calculations and gravity assists to gain or shed orbital energy. Cassini spent 13 years operating around Saturn before its final plunge in 2017. The same physics that guided it through those years can be drawn as a few simple curves on a screen. A marker appears beside a required speed value. Reach that speed on the right path, and the line opens outward. Miss it, and the curve bends back. The chart almost feels reassuring. A correction point is placed higher along the trajectory. The projected route escapes cleanly. The same correction point is moved lower. The orbit line folds inward and becomes a descent line.
Telemetry confirms
Nothing else changes.
the escape waypoint.
The calculation still works. The diagram still makes sense. The only thing moving is the starting point. And that is beginning to look more important than the burn itself. The trajectory replay begins normally. The escape curve appears. The burn marker appears. For a moment, everything looks recoverable. inside Saturn's gravity well, the correct move can be behind you. The diagram pauses. The burn point slides backward along the path. The spacecraft does not move with it. Then, the first physical barrier arrives. Saturn's upper atmosphere is not a solid roof. It is a ghost. Thousands of kilometers above any surface a person could imagine, hydrogen and helium begin pressing against Cassini. The spacecraft is not burning fuel to escape now. It is burning fuel to stay pointed at Earth. Its attitude control system has to fight the drag just to keep the antenna aligned. Every small correction spends maneuvering margin. Every gram used to hold orientation is a gram stolen from the escape bill. The display updates one last time. The required burn now sits behind the current position. The solution survived. The opportunity did not. Telemetry continues. The escape path does not. Saturn does not need to destroy a spacecraft first. It only has to keep it. Data is still arriving. Position updates still appear. The spacecraft remains visible on tracking displays. During Cassini's grand finale in 2017, the signal continued through its descent into Saturn's atmosphere. The ending was not a landing. It was a loss of signal during the fall. The trap is defined by escape energy, descent speed, and atmospheric loss, not by a surface anyone can point to. That changes the order of events. No return comes first. Disappearance comes later. Saturn's cloud bands fill the view. There is no horizon, no recovery target, no exit line. Yet Earth is still receiving information. Cassini's final signal needed more than an hour to cross the distance back to Earth. The Deep Space Network could continue hearing from it after the outcome was already decided. The last contradiction remains on the screen. The spacecraft is still measurable, still active, still speaking. Recovery has already ended. Saturn shows that some places are not difficult exits. They are conditions where return has already been removed. Falling was the boundary.